Okay, welcome back. Let's continue. One more, I guess, 20 to 30 minutes. We're going to cover what is variance and standard deviation. So let me share the screen. Okay. Okay. So as we have discussed that if you just invest in one security, the appropriate measures should be standard deviation or variance. To give you a little sense about what is variance and standard deviation, I would like to start with a simple example. Consider there are two groups, group A and group B, and we have a math test. Okay, so in group A, one student get 100, another get 0. In group B, both students' math score is 50 and 50. So in terms of, if we want to know the average of the math ability of the two groups, we usually calculate the average. So the mean value for both groups is 50 and 50. But can we say that both groups, on average, the students' abilities of math is identical? No, obvious. There's a big variance. In group A, one get 100 and one get 0. So how to capture the difference of this kind of variation? So the first thing come to our mind should be we can calculate the deviation. Okay, deviation measures how far from the mean value. So in the case of group A, the average is 50. And this means that for the student who get 100, so the deviation is they outperform the mean by 50. So its deviation is positive 50. On the other hand, another student, the deviation from the mean value is 0 subtract 50. So it's minus 50. So this means that the student who get 0 point underperform the mean or deviate from the mean value by negative 50. And we do the similar thing for group B student, and because the mean value is 50 and both students score is 50, so the deviation for two students should be 0 and 0. And then we want to calculate on average. So this group's average deviation is, so for group A, the average deviation is positive 50 plus negative 50, and positive and negative just cancel off. So the average deviation is 0. And for group B, it's also 0. But we cannot say that because of the average deviation is both 0, so both group has the same kind of variation, right? So it's obvious group A has higher variation. So this means that it's not appropriate to calculate the average deviation directly. So instead, before calculating the average, we first take the square term. So because if we take the square term, we can get rid of the negative sign and positive sign, right? So we first calculate the square deviation for each number. So for the first student who get 100, the deviation is 100 and minus 50, and the square term is 100 subtract 50 and the square terms. Similarly, we take the square term of the second deviation, and then I think we can get rid of the sign. So we don't care whether it's positive deviation or negative deviation. And then we calculate the average square deviation. So in this case, is 2,500. So similarly, we calculate the same thing for group B, and the average of the square deviation is 0 because the square term is 0, square turn 0. So by comparing the average square deviation, we can say that group A has larger square deviation. So it has bigger variance compared to group B. So exactly, so the average square deviation actually is the called variance. Okay, so variance is the mean of the square deviation. And there's a similar measure called standard deviation. And standard deviation is calculated as the square root of the variation, because when calculating the variance, we square the deviation. So in order to take account of this effect, we take the square root of the variance, and then we can get that the standard deviation for the group A is 50, and standard deviation for second group is 0. And the standard deviation has the same metric as that of the initial number. So this is the basic big picture of the variances and standard deviation. So let me quickly summarize. So variance and standard deviation are measures of variance or volatility among a group. Okay, so both A and B, they have the same average, but they have different volatility or variation. And we cannot calculate the average deviation because positive and negative deviation may cancel off. So we square the deviation first and calculate the average. That is the variance. And similar to variance, standard deviation is just take the square root of the variance, and to make sure that the number of the standard deviation has the same metric as that of the original number in group A and group B. Okay, so let's see some real life examples. So I think there are many top YouTubers. So for example, there's a YouTuber A and YouTuber B. So each day or for each video, so they have different number of view, right? So maybe it depends on the quality of the video and depends on the contents. Okay, so let's calculate the mean view for each YouTuber. So I think it's quite similar. Okay, it's around 2,800 view per video. However, can we say that A and B has the same volatility or same variance? No. So I think for YouTuber A, there is a big variance among videos. Some video has very low view, some 955. Some video has very high view, so number of views, so 7,000. So in order to capture the variance between groups, we calculate the variance and standard deviation. So to calculate the variance, let's calculate the deviation first. So after we calculate the deviation, the variance is just the average of the variance, square deviation. And by calculating that, we find that the variance for YouTuber A is significantly larger than that of the B. And standard deviation and variance are similar measures. The only difference is that the standard deviation is just the square root of the variance. So we take the square root and we can get there. The standard deviation is 2,000 view. So one standard deviation for YouTuber A is 2,000 around. So the standard deviation for YouTuber B is 2,263. So So I think the standard deviation and original number has the same metric. So it is the number of view, right? Okay, so let's do some, before we do some calculation, I would like to summarize what I have taught by using this figure. So this is the left-hand side YouTuber A and right-hand side YouTuber B. And the y-axis is the number of view for each video. So we can see that the average view is quite similar. And but we cannot say that A and B they have the same volatilities or same variance, because obviously for YouTuber A, the deviation is significantly larger than B's deviation. And because the positive deviation and negative deviation would cancel off, so we calculate the square deviation first and then take the average. That gives us the variance. And standard deviation is the square root of the variance. Okay. To sum up, to get a standard deviation, first, calculate the average of each group. And then calculate the deviation. That is for each number included in the group. Please calculate the difference between the mean value and the numbers. And then take the square term of the deviation. And then take the average. Okay, then that is the variance. Finally, please take the square term of the variance and you get the standard deviation. So I think in the finance, the standard deviation or variance, they measure the total risk or total up and down of a security, because we know that the return of a security can be probably 20%, minus 10%, and on average maybe 5%. So it's something like this. So stock return can be something like this, and the average is something maybe around 5%. So sometimes they have 20%, sometimes they have negative 20%. So we need to capture this up and down. So we can capture this up and down by first calculate the deviation and then calculate the variance and standard deviation. Okay. Then erase those. It's what a mess. Okay. And this is the equation. I generalized what I just discussed. So the variance, so please remember notation VAR stand for the variance or the sigma square. Okay. And standard deviation is, the notation is sigma. And that VAR, variance equals sigma square, which is the average of the square deviation. So this is a deviation for x2, deviation for x1, right? And the standard deviation is just take the square root of the variance, or you can simply put them in the same formula. This is the formula for standard deviation. It's the square value of the variance, and the variance is the average of the squared deviation. Okay, so let's do a simple example. So this is the stock A. So we have 3-year status. So 2015, the annualized return is 5%, 2016, 10%, 2017, 3%. So the average is 5% plus 10% plus 3% divided by 3. Okay, so we get 6%. So that means that on average, that is 3%. So if we drop in this figure, is something like this. So we have 3%, 5%, 10%. So 3%. 5% here, 10% here, and 3% here. And on average is 6%. Okay. Then let's calculate the deviation, the square deviation. Okay. For the 2015, the returns 5%. So the deviation is negative deviation. Okay. So the square deviation is 5% subject 6% and square. So this is the square deviation for 2015. And for 2016, the realized return is 16%, 10%. So this is a positive deviation. So this is a negative one. So the square deviation is 10% subject 6%. And the square term is 0.0016. So similarly, the 3% we also has negative deviation again. So the square deviation is 3 subject 6%, and the square term is 0.0009. So we already have the square deviation for 3 years. So variance is just the average of the square deviation. So that is, we calculate the average of the square deviation, and we get that the variance is 0.000867. And then standard deviation, just take the square root of the variance. So we can calculate that the standard deviation equal to 2.94%. Okay. And this is the explanation for standard deviation and the variance. Now it's your turn to do the multiple in-class test. Okay. Okay, so that's the end for today's lecture. Thank you so much.